Right. Good morning, students. So, look here. We have here one chapter that is work and energy. Already we are studying about work and energy from 6th class, 4th class also there, I know. So, work and energy. What is work? What is energy? Think a minute. Think 1 minute. What is work? Types of works and etc. When we are thinking about it, introduction to work. Look here. I want to introduce you some points. I want to introduce you some points. What concepts, I mean, what topics are given in this chapter? Look here, topics are there. Definition of work. What definition? First of all, expressions to calculate work. Expressions to calculate work. How can you calculate the work? How will you calculate the work? Expressions. Next, units of works. In which unit you are able to measure the work? Is there any unit for work or not? Look here, types of work. Types of work. Is there types in work? So we will look at it. Numerical and important questions. Numerical and important questions which are given in work and energy chapter. Look here. What all are engaged in different types of work. W for work, my dear. Don't confuse. All people can engage themselves in work. Workless people are there to roam on road. I am not talking about them. Normally, all the people are engaged in their work. When you are looking a teacher, an engineer, a doctor, collector, chief minister, prime minister, former, and coolie, daily wage coolie, even anybody, when we are looking them, they are already engaged in a proper work. They are already engaged in your work. How can you calculate their work? How can you calculate the work of farmer in his crop field? Farmer working in a crop field, yes, I can, but how can you calculate his work? That is important. Look here, my dear students. So different types of works are there. Like working in office, animals pulling cart, animals pulling bullock cart, horses are carrying us, donkeys are carrying clothes and things which are kept upon its body. So here I am thinking, I am planning to encourage you think different types of works. Children are playing. Is it work or not? Work only. Morning we are jogging. Is it work or not? Everything comes under work. But how we can calculate it, that is important. Look here. So my dear students, these are work, but the work nature is different. All those which we just spoken, We have just spoken that all works are work only. But the work's nature is different. Work's nature is different. Work nature is different. And look here, for work need energy. Yes. To do work, we need energy. When we need energy, how we can get is will you get in your market as a cases wise? Cannot. When we are having the meals, from the meals we will get the energy. From the meals we will get the energy. Here when we are working, look here. Work need energy. Energy we get from food. From food we will get energy. When we will get the energy, we can go to do work. For machines, we are using fuels for the energy source purpose. The source of energy purpose, we are using fuels for machines. Different machines are there. Animals are there. Animals purpose we are using grass or whatever they having. We are having needs to get energy to do work. Machines needed fuels to get energy to do work. Like that. Look here. Whenever work is done, a force is applied. Remember, one work done by moving saw, a force has applied. Already one force need to apply. When force is not applied, then work cannot complete. Here that only I am thinking the work when need energy. Whenever work is done, a force is applied. That causes work to happen. One force is needed. Yes. Now one chair is in the corner of a classroom. I want that chair in my position. Moving of chair is called work, okay, but moving before something you are applying. Before the moving of chair, what you are applying? So you are applying that something is called force. When you are applying force upon the chair, then chair can come from that position to this position. When you are applying force upon the door, then door can close. Door can goes forward, comes backward. When you are applying force for pulling, then door come back. When you are applying force to pushing, then door go far. Remember. Work is said to be done. Work is said to be done, but when that is important? Only when applied force. Only when applied force causes displacement in body. Correct. Look here. We are telling work is done. When you are able to tell work is done, when force is applied. When you are telling force is applied, so something is displaced. Which placed? Displaced. When I can tell work is completed, what work completed? Chair is in the corner of the classroom. Now the chair is in the position of mine. Now the chair is front of me. So I can tell that when the chair is front of me, work done. Work is to be done. How work is to be done? Work is to be done when I applied force with my hands. Applied force, work to be done. While applying force, what's happened? Chair's position change. Chair's position displaced. That chair, this chair is not there. Chair is displaced. With displacing of chair, we are telling force is applied. With displacing of chair, we are telling force is applied. While force is applied, we are telling force is applied. When we are telling force is applied, then we are telling that work is done. Work is to be done. Work done. Work need force cause displace. Work need force do displace. Force do displacement. Next. Work factors. What are the work factors? One, work factor is force. Second, work factor is displacement. Look here. What is force? Force. Force. For the work to happen, force has to be applied. Can say W is directly proportional to force. W is directly proportional to force. W is, we can say, equal to force. If W you are telling, work completed you are telling, compulsory force should apply. Force not there, then you cannot say work is completed. Work is to be done. You can't say work is to be done. When you are saying conformly work is to be done, behind of that work is to be done, force already applied. Force already applied. Next. So, can say W, work is directly proportional to force. W is proportional to force. Look at next. What is that? Displacement. What is displacement? The necessary condition for work. The necessary condition for work to be done. When you are telling work to be done, behind of the work to be done, necessary condition. What is the necessary? Displacement. If displacement not there, so without displacement work is to be done. You can't say. When you are saying work is to be done because of displacement. Displacement is there in a particular object, then you can say work is to be done. Look at that. For work to be done is that. Where is that necessary condition for work to be done is that the displacement must be caused. Displacement must be caused in body. Then we are telling work is to be done. Displacement is to be must be caused in the body. So work W proportional to displacement. Almost work W is equals to displacement. Yes. And I can tell that W is equals to almost for force, W is equals to almost for displacement. Then we can tell that W is equals to F into S. Work done W is equals to force into displacement. Direct product of force and displacement is equals to work. Product of force and displacement is equals to work. That only I did. But W is proportional to F into S, we are telling. But when you are removing proportional to keep equal, to keep is equal, then you should suppose to use proportional constant. Proportional constant K you supposed to use. When K constant you are using, constant value is 1. Don't mind. Constant value is 1. So W is equal to 1 into F into S. Is equal to W is equal to direct KFS is equal to W is equal to F into S direct. You can write. So work W is a product of force and displacement caused by force in its own direction. Work can cause by force, but force own direction. We are not telling force direction is west side or force direction is south side or we cannot say north side or we cannot say. Force having its own direction. Work W is by force in its own direction. So W is, we are telling, scalar quantity, because force not have a particular direction to complete the work. Force not having a particular direction to complete the work. That's why we are telling work is scalar quantity which have only magnitude but not direction. Thank you.